This video is going to cover more factoring techniques. So for factoring, our steps don't change. We first factor out the greatest common factor, and then we determine the number of terms and choose the appropriate method. So I know we already looked at this problem, factoring 4x squared minus 36, but I do want to look at this problem in a little bit of a different scenario. So for factoring, the first thing we always do is we factor out the greatest common factor, which, if you watched the last video, hopefully you remember the greatest common factor was 4. And we went through and we did the prime factorization of each to determine that. So this is what we had left. And then in the last video, if you watched it, we went through and we did what the directions said to do for difference of squares, because there were two terms left over in the set of parentheses, x squared minus 9. X squared is one term, negative 9 is the other term. And because it was a square and not a cube, we follow the directions that we make it into 3 terms and perform AC grouping. There is another method or way to kind of approach this problem, and that's called the difference of two squares. So in order to look at the difference of two squares, you have to have two squared terms first. Again, that's why it's called the difference of two squares, because you have to have two squares. So when we look at the stuff that's in parentheses, please realize this only works for two terms, which I have. So let's try taking the square root of each of these. So what's the square root of x squared? Again, hopefully you know these properties, that the square and the square root are opposite of one another. So they kind of just cancel out to leave me with x. And I know this is going to sound really weird, but I'm only going to take the square root of the number. So do we know the square root of 9? Square root of 9 is 3. So I do know the square root of both of those, so I can use this difference of squares. A few things I need to point out. Yes, you need two squares, which we have, but you also have to have a difference. Difference is just subtraction, so that's why that minus is important. If by some chance this was a plus sign, we could not use this method. We would have to go through and put it into a trinomial, make it into 3 terms, and try to factor it from there. But anytime you have subtraction of two squares, then you can use this method. So notice we have x squared, and then we have 3 squared. So in essence, this here will really break down into x squared minus 3 squared. And then we can follow this difference of two squares formula now. The formula says that that stuff in parentheses will break up into 2 sets of parentheses. Notice the first term in each set of parentheses is the square root of the first term of the polynomial. So the square root of x squared was x. So at the beginning, each of these will get an x. In one set of parentheses, we put a minus. In the other set of parentheses, we put a plus. And then notice a is the square root of a squared. The square root of a squared, or 9, is 3. So each set of parentheses gets a 3 at the end. And then when we look at this, you can't factor x minus 3, you can't factor x plus 3. There's my factored form. Which hopefully, if you remember from the last video, is the same answer that we got when we put the 2 terms into 3 terms and then factored a trinomial. So this is a little bit of a trick to the difference of squares. Again, make sure you realize here you have to have a difference. So So you have to have a subtraction, and you can only use this trick when you have two square terms. If you only have one square term, it's not going to work. If you have three square terms, it's not going to work. You can only use this when you're subtracting two squared terms.